All right, this is a Codelab on network security configuration for Android. How to secure your network connections and limit what your app is allowed to connect to, what URLs, whether or not clear text is allowed, and um, using certificates, or you could specify domains. So here we go. Let me make this smaller. Move this over. All right, so go to this website, codelabs.developers.google.com. Search for security, select Android, and it's this one, this Codelab. I'm going to click Start. I'm going to go to the beginning. Okay. All right. I'm going to skip past this. All right. Let me clone the project. Grab that URL. Open Android Studio. Get from version control system. Paste that URL. Clone. Go to the next one. All right, running the app. So that's what it looks like. Messages. Just fetches messages, who it's from, and then a profile picture. And then here's the interface. It uses MVP, Model View Presenter. There's the contract. There's the interface for the view. Pretty straightforward. Error, show error, set post, set loading post. And then the presenter. Okay. Go into Gradle properties. Let's run it first. Actually, first, let me open just the project, because right now, okay, see, here I am, network security config. That's what I just cloned. This is the Android project. This is the server side of the project. This is a node project. So just select the Android project and then click open. And I'm going to do this window. All right, and I'm going to change this to project view. Open that up, open this, start opening these up. Let that build. All right, now I'm going to run it. I'm going to open here, yep. Yep, there we go. There's our exactly what the Codelab shows. All right, I'm going to stop it now and close the emulator. So that's good. Now to start getting into it. I'm just going to go through the steps. I'm not going to read everything. So first, create a network security configuration XML file. It's going to be named like that. Okay. So go into res. It's going to go in here. So right click res, do new Android resource file, and that's what it's going to be named. And it's XML, and its root element is this. There we go. Click OK. Add that to Git. All right, and then here's what gets added to it right here. Clear text traffic permitted false. Okay, now we have to actually wire that up into our app, and we do it here in the manifest. We have to tell our app manifest to use that config file we just created. There we go. And we got to get rid of this. So that's another way to override it. Because by default, Android apps cannot use clear text. You have to override it to allow it. So I'm going to delete that. And now I'm going to run it. And because, so now we're using this network security configuration for our network, and we're saying clear text traffic permitted is false. It's failing. We're getting this exception here because you can see the URL is using HTTP. So this post URL is used to make the HTTP requests, and you can see it around. Oh, it's specified in Gradle. Yep. All right, I'm gonna stop this and close it. All right, so now we're getting that error text. So now if we change this to HTTPS and run it, go back to Gradle properties. So now we're not using clear text, we're using HTTPS. And now when we run it, now it works. It likes that. All right, cool. And I'm gonna go to this URL just to see. Yep, so this is what it looks like. And it iterates over that, and it goes to these images. Like if I click that image, there we go. All right, let's keep going. All right, common problem, server-side updates. All right, so update the backend to use a different one. We'll sync now. And then run the app. And I'm as well. Okay, you can see it's still, so it's able to fetch these list items, but it can't load the image. And if you look at, when you go to that URL, you can see why. The profile image is using HTTP. And even though this is HTTPS, the profile image URL is not. It's HTTP. So that's why it's getting that error here. All right, let me stop this, close it out. Okay. Now if we change it, and you notice it's v3 now, we're on for the URL. It's where that was v2. Now we're going to do v3. Sync it, and then run it. The response. If this would get out of my way. And you can see now it works on the phone because these profile images are using HTTPS instead of HTTP. Very nice. Okay. Very nice. Let me stop it. Close this. All right. Domain specific configuration. So let's grab this. All right. So this is a domain specific configuration. Let's see. There's the base config. Clear text traffic permitted is false. And then a domain config. Clear text traffic permitted is true, and the domain specified, it says include subdomains true, local host. So whenever we're pointing to local host, we can use clear text traffic because that's at the true. But we got to run the server, and so let's start the server up. We're going to do it locally. All right, so I'm using Visual Studio. I like Visual Studio. I'm going to do open folder. And I need to find that project. Where is it? It's Android Studio Projects. Okay, so there's our Android app, secure config. I want this one, server. Click open. And there we go, there's the server. Okay. Now we have to run this command. Open Visual Studio up again. I'm going to open the terminal in Visual Studio. I'm doing this in Visual Studio. I would recommend doing it with the terminal as well. I've had problems using the other terminal from Mac. So I would use the terminal in the IDE. So npm install http server. I'm not going to put -G for global. I don't want it globally, just right here for this project. ls. Okay, it says I should be inside of server directory, which I am. Cool. And then I have to run that. Okay. Now it says I should go to localhost 8080 now that the server's running. Oh, and I have something else running on that port. So let me stop this. If you don't have anything running on port 8080, you should be fine. I do. So I'm going to run this on port 8081. So for me, everywhere I see 8080, it's going to be 8081. If you have no problems on 8080, just stick with 8080. All right, now let me go to 8081. And there we go. Yep, here's my local host. I'm running the server. It's up and running. Cool. All right. Let's see. Now I need to forward port 8080 from the device to the local machine. So I have to run this ADB. It's a reverse TCP command. Let me grab this. I need to have the device connected, so I need to run it. Actually, I don't need to run it. I just need it up and alive. So I'm going to stop it. And then where's terminal? I'm going to run that command in terminal. But I don't want 8080. I want 8081. Okay. All right, there we go. So I ran that command, and now I'm going to change my URL to be localhost. And it has to be 8081 for me. And then sync it. Okay, now I should be able to run the app, and let's see what it does. There we go. Now I'm running it locally. Awesome. All right, let me stop this. Yeah, it's not secure because the URL is HTTP. We're running it locally. All right. Okay, now it says domain configuration. Let's add all this or put that in there. So it's, let's see. Oh wait, no, we weren't supposed to add that. That was just an example. We're not changing our app, so don't worry about that, what I just put in there. Okay, so now we need to create a certificate for the server, and that way it's gonna use HTTPS. So let's run some commands. This is the first one. Where's Visual Studio? There it is. All right, let me stop the server by hitting Control-C and clear this out. All right, that's the first command. That makes a private key. And then this will sign the private, or well, no, it makes the first one made a certificate, and then the second one signs the public key with the private key. Okay, or vice versa. Okay, now I need to create the DER format CRT, and that's for Android. Okay, yeah, so I'll go over these real quick. Open SSL, generate RSA, that's a key pair. The output is this PEM file right here, and 2048 bits. So you create a certificate, authority, then you sign it. That certificate is a key pair, private key and public key, and you're gonna sign it, you're gonna self-sign it. So you're gonna sign the certificate has a key pair, private and public key, and you're gonna sign one key with the other. Okay, and then let's see, create a DER format CRT for Android. This is like a certificate in a format that Android will work with. And then we want to, okay, so let's get the server running using, see the commands change. Now it says use SSL, and it specifies the PEM files that we just made to root ca cert perm. Yeah, those two PEM files to that we made from signing and creating the key pair. So let's get that up and running. Okay, let me paste it here. All right, now it's running. Let me go to that host. All right, yep. It's giving us this error because it's self-signed. Normally, you don't want to self-sign, especially like a website, because you'll always get this. You want public key certificates and signing. They get their strength from, you know, people that are trusted, certificate authorities that are trusted, signing other certificates, so they know you're trustworthy. But some places like a bank, where they don't want to be part of that whole chain, they're gonna just sign their own, or they'll have their own certificate authority. Yeah. Okay, so let's see, update the backend URL. Did I already do that? I thought I already did that. Let me check. Oh, it changed to use HTTPS now that the server's running with SSL sync. All right, now, how much battery do I have? Ooh, I'm running low. I better hurry up. Okay. Let me run this. Oh, wait, forgot to pull over. It does not have that certificate. Okay. Okay, so grab this for the config. Did I already do that? I need that thing we just created on the server. This, where is it? The debug certificate. That was for Android, so I'm gonna go reveal in Finder. Okay. And then open Android Studio and Finder up again. Oh, I need to make a raw new Android resource directory. Raw. Okay. Now you're going to drag and drop that debug certificate into that raw directory. And click refactor. There we go, that error goes away. Now it should be able to run. And it doesn't have any problems because it's got that raw debug certificate. And in our config, we've specified when we're doing debug, the trust anchor, we trust the certificates from the system as well as certificates in debug. And the reason our certificate wouldn't be recognized by the system is because it's not signed by a recognized certificate authority in Android that Android recognizes. It's self-signed. So, you know, if you're trying to create like your own controlled environment and you don't want, you don't want to establish or be part of that whole trust, you just want to completely have control over your certificates and who you trust, this is fine. Okay. Yeah, so you can see it's now accessing our local web server over HTTPS using a self-signed debug certificate. Okay. Carefully check the logcat. Okay, no, I didn't get any errors. All right, awesome. So yeah, this is a way to kind of lock down your Android app and make it so you can. It's a good practice just to it secures your network. It only lets your app connect to what you want it to. And as far as like working around this, people could argue, say, well, this is pointless because you could reverse engineer it and change it, or there's unpinning techniques. Well, that's true, but then there's other ways to make sure an APK has not been manipulated with. When you make an Android executable, your APK file, it gets signed, and so if files inside of it that were used to create that executable are changed, well, its checksum is going to change as well. And so this isn't like a end all be all, once you do this you're good, but this is part of the whole securing your Android app. So it's one step, one part of it, and you should definitely do it. All apps should definitely have this configured rather than just using the default config. You should make your own and understand how it works, set up your trust anchors, debug, all that good stuff. Hope you enjoyed it. Thanks for watching.